In this video, we're going to be looking at which variable to solve for. You're going to be given 4 different problems, and I'm going to work through each of them. In each problem, I'm going to either solve for one variable or the other, or maybe even both. You're going to need your notebook and a pencil in order to take notes. Taking a look at the first problem, we have a linear equation that has 2 variables, both x and y. We have 2x plus 4y minus 31 is equal to 123. I'm going to ask and I'm going to show you how to solve the equation first for x and then for y. So I'd like you to pause the video and write down the equation above twice. You can see that I've written the equation twice, and we're going to start on the left-hand side. We're first going to solve this equation for the variable x. So in order for me to keep track, I'm going to just double underline the x. So the very first thing that I'm going to do is I am going to look to isolate this term 2x. So in order for me to do that, I'm going to first work with numbers. I'm going to add 31 to both sides. So 31, take 31 away, or I have negative 31 and I add 31, that becomes nothing, it's 0. So I'm left with 2x plus 4y on the left is equal to, and now I've added 31 to the right-hand side, I have 154. Again, I'm looking to move towards isolating the term of 2x by itself. So now what I'm going to do is I'm going to subtract 4y from each side of the equation. When I do that, I know that I'm left with 2x on the left is equal to 154 minus 4y. I want you to remember that I cannot take 4y away from 154 because they are not like terms. So again, I'm looking to isolate and get 2x to 1x. So therefore that means I'm going to divide everything on the left by 2 and on the right by 2. So doing that, 2x divided by 2 leaves me with 1x, and 154 divided by 2 is 77, and 4y divided by 2 is equal to 2y. I now have x is equal to 77 minus 2y. I'm now going to go ahead and on the right-hand side, instead of solving for x this time, I am now going to solve for y. So I am going to double underline the y on the left, and I'm going to move towards getting y all by itself. So the very first thing I'm going to do again is I'm going to work with numbers, and I am going to add 31 again to both sides. When I do that, I am going to know that I am going to be left with 2x plus 4y is equal to 154 again, just like before. But again, this time, instead of solving for x, we are going to isolate and solve for y. So I'm going to circle that 4y, knowing that I'm going to keep that there, and I'm going to subtract 2x from both sides, noting that I cannot take 2x away from 154. Therefore, I am left on the left-hand side with 4y is equal to 154 minus 2x. Again, I'm going to continue to solve for 1y by dividing everything on the left by 4 and on the right by 4. And now this is where I'm going to show you different ways to represent this, but I want you to note that as I work on the right-hand side, these are all going to be equivalent. So the very first thing I'm going to do is that I know that 4y divided by 4 is going to give me 1y. And this time I am going to use a calculator. And 154 divided by 4 is equal to 38.5. And if I divide 2x by 4, I know that is equal to 0.5x. So that is definitely one answer. I could have left 154 over 4 as a fraction. So there's another way to do it. 154 over 4 minus 2 over 4x. That's another equivalent equation. I can go ahead and simplify 154 over 4 by dividing the top and the bottom by 2. Therefore, I get another equivalent equation of 77 over 2. And I know that 2 over 4 can be simplified to be 1/2 x. That's another equivalent equation. And I could do it one more way, knowing that I can, because I have a common denominator of 2, I know that this is a lot. I can go y is equal to 77 minus x all over 2. So again, all 4 of those equations are equivalent. But I think if I looked at just this one here to be the easiest one to do, that's what I would have done. Moving on now, we are going to look. I want you to go ahead and pause the video right now and get all of this down. So therefore you've got it. And then I am going to go ahead and move on and look at the next problem. So in problem number 2, we have a chef that bought $17.01 worth of ribs and chicken. Ribs cost $1.89 a pound, and chicken cost 90 cents per pound. The equation was given to us as 0.90c plus 1.89r is equal to 17.01 because it represents the relationship between the quantities in this situation. Again, I want to reference 0.9 references the cost of the chicken per pound, 1.89 references the ribs cost per pound, and 1701 represents the total that the chef spent or bought. We're going to, in this case, solve the equation for C and then explain what it means in the context of the problem. So I'm going to go ahead, and the very first thing I'm going to do is I'm going to rewrite the equation and underline the variable that I'm going to be solving for. So you can see that I've rewritten the equation, and because I'm going to be solving for the value of C, I'm just going to underline that term in order for me to keep track. So the very first thing I'm going to do, like I did in the first problem, is I'm going to isolate and get C to be by itself. So in order for me to do that, the first thing I'm going to do is subtract 1.89r from both sides of the equation. You're going to remember that I cannot subtract 1.89 from 1701 because they are not like terms. So that means I have 0.90c is equal to 17.01 minus 1.89r. Again, I'm going to underline knowing that I've got to get C all by itself. Therefore, I'm going to divide everything or both sides by 0.90 or 0.90. So that means on the left, I've divided it, and I'm going to take each term and divide each term by 0.90. I'm going to go ahead and use a calculator in order for me to do that. When I use my calculator to divide 17.01 by 0.90, I get 18.9. And when I use a calculator to take 1.89 and divide it by 0.9, I got 2.1. 2.1, and I need to put the R there. So now you could see that I solved for just the variable of C. So now I have to look and decide what, if I did that, if I solve for the value of C, what is that going to give me? So I want you to think about, what does C stand for? We know that C stands for the pounds of chicken bought. So I know that the amount of chicken, the cost of chicken per pound was 90 cents per pound. So this 90 represents the cost, and the C represents the pounds of chicken. So if I was a chef and I wanted to know, okay, this is how much I spent total. If I know what the cost is of chicken per pound, I can figure out how many pounds of chicken I either bought or need to buy. So moving on and looking at problem number 3. Go ahead and pause this video. Make sure you get everything down on this slide so you can then move on to problem number 3. So you can see here in problem number 3, we're talking about the area of a rectangle. And if you can remember that the area of the rectangle is represented by the formula of A is equal to L times W, where L is the length and W is the width. So I'm going to stop right there, and I'm going to go ahead and draw this out. Just draw a rectangle and just draw it to represent what we've been given. So you can see that I drew a rectangle, and I want you to remember that the area is the space inside, and that we've got the length on the bottom and the width. So if I wanted to find the area, I would multiply the length times the width. So in this situation, we are given that the length of the rectangle is 5. So I'm going to write that L is equal to 5. What we're supposed to do is we're supposed to just write an equation that I could use to find the width. I'm not going to solve for the width. I'm simply going to set up an equation to solve for the width. So what I'm going to do, the very first thing I'm going to do is I'm going to write my equation of A is equal to LW, because that means length times width. And I know that I'm being asked to find the width, to write an equation to find the width. So the very first thing that I'm going to do is I'm going to underline the W, because that's what I need to solve for. So if I look at that, I know that I need to get the W to stand all by itself. So that means if I'm multiplying length times width, that I need to divide both sides by L in order for me to get W to stand by itself. L divided by L is 1 W. And on the left-hand side, I have A divided by L. Therefore, I could write the following, and you're going to see me rewrite this to put W on the left. I'm going to write that W is equal to A divided by the length, which is L. So now I can go one step farther, right? Because I've been given that L is equal to 5. Therefore, what I can do in order to solve for the value of W, I can substitute L for 5, which means I know that W is equal to A divided by 5. And that's all I need to do, is simply set up the equation knowing that I can find W by taking the A when I'm given the area and dividing it by 5. Go ahead and pause the video here in order for you to be able to move on to the last problem, which will be problem number 4. Here's our last problem that we're going to look at, solving for one variable within a formula. So we are given the formula of V is equal to pi r squared h. This is an equation that is used to calculate the volume of a cylinder where cylinder V, where R represents the radius of the cylinder and h represents its height. So what I'm going to do is quickly sketch out what we're referring to here in this problem. So just really quickly, I just want you to remember, here's a cylinder. We know that the radius has to do with the circle. So the radius goes from the center of the circle out to the edge of the circle. That's the radius. And I've got the height of the cylinder. Remember, a cylinder can be filled with water or some kind of a liquid, and that's or something relating to volume. It could be beans or something like that. But anyway, so it could be a can, like a cylinder, if you think about that. So that is what we're looking at. So what we're going to do here is we're given the formula V is equal to pi r squared times h. And what we're going to do is I want us to solve the equation for us to easily find the height. So in other words, what we're going to do is we're going to solve for the variable h. So I'm going to go ahead and I'm going to do all of the same kind of methods that I did previously on the previous 3 slides. So we know that we want to solve for h right there. So the other thing I want you to remember is that we are multiplying pi and r squared by h. And I've got V over here on the left-hand side. So that if I am multiplying pi times r squared times h, in order for me to isolate the h to be by itself, I am going to divide both sides by pi r squared. Both sides by pi r squared. So let me go ahead and clean this up a little bit so it's a little bit easier to represent. Okay, so what you've seen me do is all I did was rewrite the formula again. V is equal to pi r squared times h. I underline the h because that is what I want to solve for or to isolate. So what I did was, because I am multiplying pi and r squared by h, all I need to do is, in order for me to get 1h, I'm going to divide both sides by pi r squared. So look what I did here. Divide by pi r squared, divide by pi r squared. So now what am I left with? I know that pi divided by pi is 1. R squared divided by r squared is 1. So this is 1. This is 1, and 1 times 1 is 1 times h. So this is what I've got on the right-hand side. So what do I have on the left? I have V divided by pi r squared. So now I'm going to go ahead and clean it all up because we never write 1 times 1 times h, because we know that that just means it's h. So now I'm going to put the h on the left-hand side. And I know that h is equal to V divided by pi r squared. So there you go. There is my formula to easily find the height of my cylinder. So hopefully you got all that down. You could go back and rewatch and take your time. You could stop the video. So those are the 4 problems that I went over. And now we're going to do some more practice in class.